Good evening, everyone. Welcome to a lesson about graphing parabolas. I expect you to use this video as a short warm-up to getting to know the information that we're going to use tomorrow, so whenever you come into class tomorrow, we can jump right into actually graphing some parabolas. By the end of the lesson, you're going to be able to see how changing the parent function, which is y equals ax squared, by a constant is going to affect the outcome of the graph of the function. You will also be able to evaluate the location of the vertex of the graph of a function by using the zeros of a given quadratic function. Now, if you notice parts of a parabola, a normal parabola is a U-shaped curve. It could either be going up or down, but it is always a U-shaped curve. Because of that, there is going to be a vertex of the graph. Vertex is the general form that you would use to refer to a parabola if you do not know whether it is opening up or down. If you do know, then we would call it either a minimum or a maximum more specifically. For a graph that's opening up, as this one is, there is a minimum or vertex to the graph. If it were opening down, then there would be a maximum. Your line of symmetry for the graph is an invisible line, but it is a line where you could place on the graph in order to fold the graph in half and have the two sides match up perfectly, also known as reflection symmetry. The line of symmetry for this graph would occur at this vertical line, which we would define as x equals 0. Now this is the graph of the parent function y equals ax squared. Every graph that we use for the rest of the lesson will be used based on seeing how it moved from where the parent function was. And that is also how we define the vertex form for an equation of a parabola. Any parabola can be written into the form y minus k equals a times the quantity x minus h squared. Now that equation sounds a little bit weird until you actually know what the parts stand for. But if you notice, it looks a lot like the parent function. There's just a few extra pieces. The parent function did have y equals a x squared. It did not have the minus h or the plus k though, so now we have to define what those elements represent. The line of symmetry for the graph could be defined by x equals h. So if we have this equation, we can define x equals h. If we do not have the equation, we could look at a graph, like the one that I have here to the right, and actually define what h would be for the graph without actually seeing the equation, just by knowing where the line of symmetry is occurring. We can define the vertex for the graph at the ordered pair h, k. And finally, you can tell if the graph is going to open up or down based on the value for a. If a is greater than 0, then the parabola will be opening up. If it is less than 0, the parabola will be opening down. You can use that information in reverse as well. If I were to give you a graph as the one here, you could look at the graph and figure out whether a will be positive or negative based on the direction that the graph is opening. Let's learn a little bit more about this example that I have here. Let's actually define the parts to it. So, you notice the parent function had a vertex at 0, 0. This graph does not have a vertex at 0, 0. It has a vertex over here. So we cannot define it exactly as the parent function. You can tell that this parabola is opening up by looking at it, so that allows you to know that a is going to be greater than 0. Next, you can see that the vertex for this graph is at 1, negative 2. That allows you, because I just told you the vertex can be defined as the ordered pair h, k, we now know that h is equal to 1 and k is equal to negative 2. The line of symmetry for this graph is at x equals 1. You can see that by looking at the graph. If you were to place a vertical line right here at x equals 1, the graph could be folded in half and have the two sides match up perfectly. Finally, using all of these parts, you can write a basic equation for the graph. Y equals a times the quantity x minus 1 squared plus negative 2, where we have substituted the values for h and k into that basic equation for vertex form for a parabola. On the second example, we have a graph that is opening downward. It's opening down, and it has a maximum. So we know that A is less than 0. The vertex you can see is happening at 2, 1. And as I just said, that vertex is considered a maximum because it is the highest point that this graph reaches. Because the vertex is at 2, 1, we know that h has to equal 2 and k has to equal 1, which, as you saw on the last example, will allow us to write the equation for the graph. We can also say the line of symmetry is happening at x equals 2. And finally, the equation for the graph is y equals a times the quantity x minus 2 squared plus 1. Now it's your turn. Please note for this example, I expect you to come into class tomorrow with your answers to all 5 of these parts. Please make sure that if it asks you to explain, that you do explain where your answer came from. Also, please note that the intervals on the axes for this graph are not counting by 1, they are counting by 2, so be careful when you're defining where your vertex and your line of symmetry are. First, you must say, is A positive or negative, and explain how you know. Then, what are the coordinates of the vertex? Third, what are the values for h and k? Next, write an equation for the axis of symmetry, and finally, write an equation for the parabola in vertex form. Please come in tomorrow with any questions that you had about this lesson, and then we can get started on graphing. Have a good evening.